If you were to give somebody directions to your home, you might do it a couple of different ways. Let me give you directions on how to get to the grocery store from school. So if we were going to go from school, somebody might give you directions that sounded like this. Go out the west entrance of the high school, head south on East Street, then head west on Randall Street. About 2 miles on the north side of the road will be the grocery store. If somebody else was going to give you a different set of directions, but to get to the same place, you would equally understand it, hopefully, and it might say, head out the Grove Street entrance of the high school and turn left on left on East Street, right on Randall, and on the right-hand side, about 2 miles down, you'll find the grocery store. So just like that, when we're giving directions with vectors, it's kind of the same thing. There's several different ways to give directions. The length of the vector, of course, should be proportional. So if it's a bigger number, it should be longer. If it's a smaller number, it should be shorter. If you had the number 10 and the number 20, obviously the 20 should be twice as big as the 10, or the 10 should be half as big as the 20. They should definitely be proportional. To give the direction portion of the vector, because remember vectors have two parts, magnitude and direction, it can actually happen in several different ways. So we have to learn several different ways to give the direction portion of a vector. One of the methods is to just give you a number, like 130 degrees. And what you need to do if you're given just a number is you need to start by facing due north, just like on this slide. The vector right here is facing due north. And then you would go around in a clockwise fashion the total number of degrees. So if you were to head all the way over to east, that would be 90 degrees because it makes a right angle right here. And if you continued on past the 90 over to over to this part right here, that would be a total of 180 degrees because it would be 90 plus another 90. If I added 90 more, this direction right here would be 270. And if I went all the way around, of course, you know that that would be a complete circle or 360 degrees. So 130 would look something close to this. I'm traveling around, right there's about 45 degrees clockwise, and then I've got about 90 degrees clockwise, and 130 would be somewhere right about here, give or take a little bit. So in essence, 130 degrees really kind of means southeastish, if you will. So they're going to give you directions where they just have a numerical value, and you kind of have to figure out which way that's going to point. The second method for giving directions is a method that looks like this, where it says something like north 30 degrees east. Because north is written first, you would face north first and then head 30 degrees towards the east. So that's what the arrow would look like. If you look at the next one over, you have south 10 degrees west. Because south comes first, you would start by facing south and then turn 10 degrees towards the west, and that would give you the direction of the arrow that you would have to be drawing. Now we usually write it with the north first or the south first. Sometimes you see it a weird way. The next slide to me is weird. This one doesn't feel natural. It says west 70 degrees north. So again, because west comes first, you would face west, and then you would turn 70 degrees towards the north, and that would be the direction that this vector would be pointing. This one starts with east. Again, it doesn't seem as natural as starting with north or south, but very possible for somebody to give you directions like that. Now, sometimes you'll see directions that look like this, where it says 30 degrees east of north. I like to say it a different way because then it makes a little more sense to me. 30 degrees east of the north line. So I take myself and I face myself along the north line, and then I go 30 degrees on the east side of that line. So that's kind of how you say directions that way. Some people like north, south, east, west. Some people like left and right when you're giving regular directions. It's kind of the same thing here. It just depends on what the person's preference is, how they give you directions for the vector. This last one, the last slide here, I wanted to show you that there's a pattern. If you take west 70 degrees north and you take that W and put it on the end, you'll notice that it looks almost the same, 70 degrees north of west. If you take the west and put it in the front, it looks similar to this one, west 70 degrees north. And indeed, both of these actually point to the same spot. So, just wanted to show you that they really actually do mean the same thing. So what we're going to do is we're going to take those directions now, and we are going to draw out some vectors next. And we're going to make sure that those vectors are pointing the right direction, that they're proportional to each other depending on the size or the length of the vector. And then what we're going to do is we're going to try to figure out what the resultant would be and possibly even the equilibrant.